So now let us look at the topic of functional inequalities. So this type of inequalities involve certain standard functions. So the first type of functional inequality are the inequalities involving modulus function. So we know the definition of mod x. F of x is equal to mod x. So what is the definition of mod x? Mod x is a piecewise defined function which is equal to x if x is greater than or equal to 0. Mod x is equal to the same number as x if x is a number which is greater than or equal to 0 minus x if x is less than 0. That's the definition of mod x. That is, if you have mod of 2, this is exactly equal to 2 because 2 is positive. What is mod of minus 2? Mod of minus 2 is equal to minus of minus 2. Because this minus 2 is negative, you add one more minus to it. So minus of minus 2 becomes 2. So effectively, whether x is positive or negative, the output will always be positive. So now, once you understand the definition of mod function, so what are the types of inequalities that you encounter using this modulus function? So, types of inequalities that you get. So, let me chalk out the basic types. So, mod x is less than a. Mod x is less than a. So, example, if you have mod x is less than 2, so what should be the solution for this? So, if mod x is less than 2, then x belongs to the set minus a to plus a. That's the solution for this. That is, if mod x is less than 2, that means the value of x, the absolute value of x should be less than 2. So, on the positive side, if x is in between 0 to 2, if x is belonging to 0 to 2, mod x is in between, mod x is less than 2. Similarly, if x is belonging to close 0, minus 2 comma 0, on the negative side, if x belongs to minus 2 comma 0, also after taking mod, you get a number which is less than 2. So, mod x less than 2 implies x belongs to minus 2 comma plus 2. You need to remember this. This is a very frequently asked inequality. If mod x is less than a, then x belongs to minus a to a, provided a is a positive number. And if a is a negative number, x belongs to null set if a is negative. Mod x can never be less than a negative number. If I say mod x is less than minus 2, mod x can never be negative, so how can it be less than minus 2? That means x belongs to null set. There is no solution for this. So I hope you are clear about the first type of inequality. And the parallel for this is mod x is greater than a. So if you have equality here, you have a closed interval here. So mod x is greater than a. So what is the answer to this? If mod x is greater than a, x is either greater than a or less than minus a. So on the positive side, if x is greater than a, then mod x will be greater than a. On the negative side, if x is less than minus a, also mod x will be greater than a. So if mod x is greater than 2, this implies x should be greater than 2 or x should be less than minus 2. These are the two options that you have. So mod x greater than a implies x is greater than a or x is less than minus a. So if a is positive and if a is negative, x belongs to real numbers if a is less than 0. So if I say mod x is greater than minus 2, so mod x will be greater than minus 2 for all x belongs to real numbers. Because mod x is always positive, every positive number is greater than minus 2. So I hope you have understood the first two types of inequalities. Mod x is less than a, mod x is greater than a. Mod x is less than 2, mod x is greater than 2, for example. So now let us go to the further inequalities. So the next type of inequality is something like mod x is in between a and b. Mod x belongs to a comma b. That is, a less than, you can have equality also, a less than or equal to mod x less than or equal to b. Mod x lies between a and b. Let us assume that a and b are positive numbers. A comma b belongs to positive real numbers. Now what is the solution for this? So if mod x lies between a and b, there are two options. So if x is positive, mod x is equal to x. So x has to lie between a and b. X has to lie between a and b. Or if x is negative, so minus x can lie between a and b. That is, x lies between minus b to minus a. These are the two options. That is, for example, if mod x lies between 2 and 3, so what can you say about x? So x can lie between 2 and 3. If x lies between 2 and 3, mod x also lies between 2 and 3. Or x can lie between minus 3 and minus 2. So these are the two options that you have, either 2 or 3 or minus 3 to minus 2. So you have three types of inequalities. Mod x is less than a, less than or equal to a, greater than a, greater than or equal to a, between a and b, less than or equal to, greater than or equal to a and b. So this is when a is positive. A and b are positive. If a and b are negatives, this does not have any solution. If one of it is positive and the other is negative, then you can have different solutions.